Hey everyone, it's me Steve. It is March 29th, 2019. Time's about 12:11 right now. It's Geo-Rant time, number 98. I'm going to do these two back to back. Well, I got my author's copies of all three of these books, and as I said, Geo-Rant 97, 98, and 99 are going to be about these. This one's already done. That was the last one. We are going to do this one. This is lab reference book classifying sedimentary rocks via visual methods. Like I said, this isn't for detailed petrographic analysis like using thin sections. This has some, that's one of my Indiana geodes there. All the pictures you see in these books, I'm pretty sure they're all mine. Yeah, I think they all are. I think I got rid of the ones that weren't. So all the photos in here would be mine, but this one has some useful, like I said, this is also not a teaching guide. It's a reference book. It's also in full color like the igneous one was. It's got that glossy coat. There's some stuff, you get grain size analyses, stuff like that in the sedimentary one. The sedimentary one focuses mostly on sands. The reason being is because sandstones, we can visually see the grains really easily. Mudstones too are a big one in here. Conglomerates not so much actually. A modified bedding scale, there's stuff like that in here. Induration, relative hardnesses. Oh, color and mineralogy. Remember I said you can never use color to identify a rock? Well, color can clue you into what minerals may be present, at least in sedimentary rocks, not so much in igneous and metamorphic. Common sedimentary minerals and their basic characteristics. There's several pages of that. The book is divided into, let's see, I'll probably tell you what it's divided into. It's divided into, this one is 4 parts. The first part was the general sedimentary rocks and their textures, like I was showing you. Part 2 would be clastic rocks. And those are your sandstones, your conglomerates, your greywackies, your mudstones, things like that. Ternary diagrams here if you want to use them. Let's see. Part 3 is probably... I wrote these things and I can't even remember how I organized it. Part 3 would be your non-clastic rocks. Oh, and here I do go through aeronites. This is still clastics, by the way. Aeronites, wackies, and then, percent mud. Now we're going to get into the non-clastics. Those would be like your chemical, or I divided in clastic and non-clastic instead of clastic and chemical and organic, because limestones, actually this is a dolostone, Precambrian, borderline marble. You could technically probably even call it a marble, but this doesn't have a lot of crystalline structure to it, so it's more appropriate to call it a dolostone. I just put non-clastic rocks together instead of separating out chemical and organic, because technically carbonates, they can be chemically precipitated or they could be due to biological activity, but they're not truly organic. They would be biological rocks. Organic rocks are things like coal, things that actually include organic carbon compounds to them. Carbonate rocks, are a special case. So, can kind of be either or. So I just put non-clastics. Crystalline structures for carbonates, classification schemes for classifying carbonate rocks. Oh, this is to scale this. You see this here? This is just to let you know. A lot of carbonate rocks will be crystalline. They're recrystallized, especially dolostones, limestones, stuff like that. But they're not metamorphic. But it's important to know the crystallization. Then I do get into some purely chemical rocks. Chert's another one that could be either or. Sometimes in Phanerozoic cherts you'll see like actually macrofossils in them sometimes, but in Precambrian cherts we don't think they have anything to do with life at all. Well, outside of banded iron, the ones in banded iron formations do, but like your cherts that you find in like slates and stuff, that's probably plus derived. We usually only see them in the Precambrian Proterozoic glacial deposits. But anyway, there's a short page on chert. Evaporites are purely chemical. And there's the basins you'll find them in mostly throughout the Midwest. I treat banded iron, although, life. We still argue about whether these are inorganic or life has something to do with these. Life does have something to do with them because you can actually find stromatolitic mats in them. It's probably a combination of both. Probably like limestones. Limestones can be precipitated out of solution chemically, or they can be skeletal remains of life forms or their waste products. Banded iron formation is probably the same, because the interesting thing about banded iron formation, other than Earth no longer makes it, is that it was dominant until carbonates started becoming a dominant, and we didn't really start getting thick carbonates until we started getting free oxygen in the atmosphere. And I know correlation isn't causation, but that's a huge shift. And banded iron formations persisted well past when we started getting free oxygen in the atmosphere. At about 2.5 billion years ago, and this has nothing to do with the book here. And then when you get between 2.5 to 1.85 was like their heyday, sort of. So we still had oxygen in the atmosphere, and they're still going strong. But about 2.5 billion years, we start seeing carbonates. Okay, but after 1.85, we have them, but they just drop off. Banded irons become boom, and carbonate production explodes. So it's, banded iron formations last, the youngest one's 800 million years about. So, maybe it has something to do with it, maybe it didn't. Gray wackies, I do address gray wackies and turbidity cycles in here, and I actually hate the term gray wacky. I explain why in the book. I think that's, mudstones is not a very thick section in the clastics. I'm jumping around here, but I do have, this is within testing. This is my own chart I derived. This is for testing carbonates. So now I'm jumping back to non-clastics. Sorry. But this is just my personal experience has led me over the years to devise this chart on the right here for testing whether rocks are carbonate or not in a lab setting where you don't have petrographic analysis, the ability to do thin sections and stuff. And I do address coals very briefly. But remember, all these books focus on the Midwest, right, of North America. But anyway, that's it. I hope you learned something. If you have any questions below, feel free to ask.